Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, it's Carl here from LunchboxSessions.com. Welcome back for our third and last part where we look at cylinders that refuse to stay in place when we need them to, using pilot-operated check valves to keep the cylinders locked in position. There was no evidence of any external leakage around the cylinders, their hoses, and fittings going back to the valve bank, which means that the valve bank itself becomes quite suspect. If we're worried at all that there have been any issues with an electronic control problems where perhaps some signal continues to be sent to the pilot valves that may have left the spool in partial drive position, quite often that can be easily eliminated by disconnecting the connectors to those valves and killing off any electrical signal altogether and finding out if the cylinders still move out of position at that point. But remember, we were primarily troubleshooting a problem related to field forces. The operator had gone into articulation mode. That's the purpose of this particular section in the valve bank. He'd gone into an articulation angle and was grading, was not using the valve handle to change articulating position, and somehow the cylinders were drifting out of position, which made the pilot-operated check valves our prime suspect. We talked about the possibility of fluid coming back from the cylinders, perhaps containing a chunk of piston seal or a steel sliver from the worn cylinder itself getting stuck on the poppet and seat when the check valve goes to close, something that could certainly happen. The thing about that particular fault is that once the valve is moved in the opposite direction or even opened again in the same direction, quite often a chunk of contaminant that came to be lodged on a poppet and seat is cleared away. So more likely is that perhaps some mechanical erosion has been taking place to the poppet or seat itself, where hard particles have been grinding away at the smooth finish of the poppet and the seat, or also a possibility that the piston itself has gotten stuck. There may be some contaminants that occasionally are jamming the piston in a position where the springs or the field pressure is not being allowed to fully close the check valve poppet due to the piston not returning to the perfect center position. So these are all possibilities to explore. Let's now change over from the articulation section on this particular grader. Let's move down a few sections on the valve bank. It's a valve bank made up of a number of valve sections all bolted together. So let's move to the blade lift. Did you see what happened there? We'll go back to articulation, have a look at the piston, the length of the spool in the cutaway, look at it also in terms of the symbol, and let's go to blade lift. So what we find out now is a number of things have changed. Our spool is longer. The pilot cap down here on the left side of the valve bank is longer to accommodate it. Our pistons for piloting the check valves off the seat have been split. It used to be a single piston, now it's two pistons. That's a very peculiar change. So this is the blade lift function, and the operator wants to have the option of allowing the blade to float freely with the contours of the ground. Perhaps instead of cutting with the blade, the operator just wants to move loose materials that are in high spots and deposit them in low spots on the terrain that he's grading. Well, notice what happened here at the check valves. The plumbing arrangement has changed. I'll go back to a standard section like articulation, where we can see that check valves are typically cross-piloted. Only one check valve is being piloted off its seat at any one time. Both check valves open, but only one requires the pilot signal. So why use a scenario like this where we are positively piloting both check valves off the seat? That's a very curious sort of a change to notice. Well, that's not the only change that has occurred there. Our spool is much longer. We have this fourth position far down on the right. If we move the spool all the way to the left, we are now in float mode, that mode where the operator may want the cylinder to move freely with the ground. And how could you possibly achieve that if you're not using the directional valve to pilot one of the two check valves off of its seat? You would be locked in position. But no, if I grab a hold of the cylinder here and emulate changes in the terrain, you can see that fluid can now come and go freely from the lift cylinder for the benefit of our floating contour work. So that's a very handy thing. And in fact, what has changed here is that we now have a special section of the spool whose only job is to take pressure from the pump. And no, not really flow, right? We're not really pushing any flow through. We're just taking the pressure signal provided and pushing it through to lift both check valve balls off the seat. And since we have to lift both simultaneously, we now have split piston, 2 separate pistons. So we have a few more components involved in this section. So if we were back into a scenario where we're expecting our cylinder to stay locked in position and not move, we're just back into a regular blade positioning for cutting at the ground. Now we have a few additional pieces to consider for parts that may be sticking due to contaminants and allowing fluid to leave the cylinder through check valves that should otherwise be locked. All right, hope that's been helpful. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.